That's okay? Too much noise? All right. Well, I'm Dr. David Reitzel. I'm from Griffith Observatory. I've been mostly the MC here today. It's been a pleasure to be here. So I want to thank Alec for inviting me to be part of this amazing Exoplanet Day. And of course, I want to thank Ken as well, Ken Harrell, for inviting me and yeah, setting stars to put together a day like this as their first event. Pretty amazing. So I feel very privileged to be here today. And I want to talk a little bit about the question that so many of these talks have gone right up to and even just opened the door and said, well, we are interested in life. We want to know, is there life in the universe outside of Earth? Now, I think most folks in this room probably have an opinion on it. How many of you think there's life somewhere out there beyond Earth? Almost everybody. How many of you think there's not, that Earth is it? Oh, there's a few. Yeah, there's a few. We don't know. We don't know. It is one of the great unsolved mysteries or questions we have in science, and we want to know the answer to this. And I think even if we found microbes on Mars, it would be pretty profound. I would want to know, do they share a similar DNA to us? Because we might be Martians. Mars should have been habitable even before Venus, I think, is the calculation. Venus would have been habitable a long time as well, but Mars should have cooled down a little quicker. It's a smaller planet. So it might have gone through its phase of habitability earlier, so it might have been the first. This is a beautiful artist rendering, of course, of the Kepler telescope and exoplanets around stars using sort of a starry night look to it, which I just think is a lovely, sort of humanizing the idea of looking for exoplanets. Now, like I said, this is the idea a lot of us have of exoplanets. It's an artist rendering, animated well, and I made this joke when I opened today of this is really what most of us saw when it came to exoplanets. I grew up watching the original series. It was on every night at 5 o'clock, and my parents were nice enough to let me watch Star Trek from 5 to 6, and then we'd have dinner at 6 o'clock. And I remember those nights where Mom would say, "Okay, dinner's ready," and I'd be like, "But Mom, it's 5 minutes till," and they would let me watch the end of the episode. So I was very lucky to have parents that wanted to inspire me and thought about it. We've mentioned how the first planets that were discovered were kind of by accident around these pulsars because they noticed the pulsars were behaving kind of strangely, that they were being yanked around by something. So they found some planets around them, but we're not finding a lot around those. Then we fast forward to the hot Jupiters. Well, that's not a great place for life as far as we know. That was 51 Pegasus. It's very close to a star. It orbits very, very quickly, and it's super hot. Again, life like us that needs liquid water, bacteria, things like that, things we can recognize easily, we're not going to find it there. The rate of exoplanet discovery, though, has been astounding. It's the only point I want to make on this plot again is this is animated. You can see in 2014 we got really serious about it. And then finally, this is not animated, obviously, but you can see the other spikes in there from the Kepler program, staring at that one spot in the sky. What they would do is they would analyze a bunch of stars. They would verify through citizen science, through many people picking the same transits, picking the same dips to verify these things are real. Also, spectroscopy was often used, follow-up studies of the stars, getting the rotation rate of the star to know whether the sunspots or star spots that are crossing the star, so you can measure those and have them different than the planets. A bunch of work goes into it to verify these, and that's what they're waiting for on the TESS mission, is they have all these candidates. Yeah, they found a bunch of exoplanets already, but they're going through that verification process, and M-dwarfs aren't easy. They flare, they have all sorts of activity, so they're a little bit of a mess. But this rate of discovery has been pretty impressive, maybe slowed down a little in the last couple of years because, again, TESS missions kicking in, but we'll get there. This animated one I really like. So this is the number of planets we've known about since early ages. Now, obviously, they don't add in Pluto. This is from current definition of the planets. So you have our first solar system planets, and they start to find more of those. And then not a lot. We've got 8. Now, they found Ceres in, what, 18, was it 99? 1900? Anyway, it was right around the turn of the century, of the last century. And it was a planet for a while, and it was reclassified as a dwarf planet as well, or as an asteroid. So finally, we start finding planets around other stars. And this is where everybody starts to get excited. Hey, maybe we will find life. Maybe we'll be able to come up with a mission to find an Earth-like planet. And again, Earth-like is something the size of Earth, something about the mass of Earth, something that could have liquid water, so you need to be the right distance from your star. So we're looking for them. We're thinking, could they be in here? But you notice we're not finding the stars in the right spot. We're finding lots of massive stuff, things that are big, and we're finding them close to their star. Why? Those are the easy ones to find. Of course, it's like, you're wandering around finding the little tiny Earth going around its star. It's not so easy. So, but we've made progress. We really have. Again, this is sort of the zoo of exoplanets. There's all sorts of out there. There's big ones, there's small ones, there's hot ones that are gassy, there's tiny ones that are hot. It's all over the place. Literally, the diversity of exoplanets. Oh no, I just got banned. My paper was just removed because I used the word diversity. That's the sort of stupidity that's going on right now, by the way, because this is true diversity in exoplanets. I mean, and some of these ones with rings, they've seen hints of rings around them. I don't think they're just making this stuff up. You see little dips in the data on even sides, left and right of the exoplanet, and it keeps happening. Maybe that's a ring around this thing. Here are the rocky worlds, and they've ranked these from icy on the left and hot and molten on the right. So somewhere in the middle there, you're going to have something that can have liquid water that are rocky, but none of them are really around a sun-like star just yet. We're making images of planets, but again, the Habitable Worlds Imager that's going to be coming to be able to find those Earth-like planets, it'll get pictures like this if we fund it. We need to be funding these cutting-edge research projects to be able to get them done. Well, I want to talk about habitable worlds, because if we're going to go looking for alien life, probably want to look at habitable worlds. This was a catalog put together by the folks at Puerto Rico, believe it or not. This was done by Arecibo, was housed at the same university there. I always liked it, but I like to think, what do we expect life to be like? And I had a professor, Bert Jones, that would talk about life in the universe, and he would bring up something like this. In fact, he would show the movie clips. He would show a clip of E.T., and E.T. being all nice, phone home, I'm going to eat some candy with Elliot, and, it's all a loving time. Or Alien, which, okay, there are no children in the audience at the moment. Of course, horror film, the aliens killing people and eating them and acid, and, it's just this horrific idea. Great fun, I think, but horrific. So which one's right? What are we going to run into out there? Well, the reality is probably much, much stranger. The reality is life on Earth is all over the place, and these are more of a reflection of humans, I believe. This is sort of traits that humans have. We can be very loving, and we can be terrible to one another. So I think Hollywood is exploring the human condition here, not so much what we should really expect from aliens. So don't take what you see in Hollywood necessarily as truth of what we can find out there. Okay. Oh, that was the wrong slideshow. Let me open the other one. It's fine. They started the same way, so find a actual mouse is nice when it works.
It's a bonus.
It's a bonus. Come on, you. No, it doesn't want to open.
This is my setting stars workspace. My work
Is it setting?
Windows 11.
It's opening on another. Here, I know how to do it. I'm smart. I've used PowerPoint before. There we go. All right, so let's scroll down to where I want to be here. Habitable worlds. All right, habitable worlds. But let's. Oh, we got to start again. Slideshow. Come on, you. There we go. Hooray, technology. All right, so what I want to show is some of the data of what they're finding. In the Planetary Worlds catalog had interesting plots. I liked them because they were in color. The one on the NASA Exoplanet Archive was not. So this is a little older. I think it's from maybe January, April of 2024. So a little old. The latest test things aren't in here. But what's interesting about this is if you want to find an Earth-like planet, you can't just have the right size. You need to have the right density. So you want to be the right mass and the right size for the exoplanet. And you'll notice down below, well, we have pure water worlds. That's the dashed blue line up above. Now, of course, the world isn't really pure water. It's going to have a rocky core. But if you have a lot of water and then a gassy atmosphere, you average out to the density of water. So those worlds probably do have a lot of water. Those that are less dense than water, those are like Saturn's. Saturn would float in a bathtub big enough, people like to say. If you get down lower, you'll cross finally sort of that, I don't know, Earth-like, dirt-colored line. Well, those are the ones that have a density similar to Earth. And there, sure enough, are a bunch of exoplanets there. So we found a bunch with the right density. The problem is they're not necessarily in the habitable zone. So we're finding them with the right density, but they're too close to their star, so they're super hot, or they're too far, they're frozen. You need to be in sort of this green range. It's, the Goldilocks. Oh, I'm too hot. Oh, you baked all the water off my surface and all the life is dead. Or you're too far. Oh, you froze me and all the life is, well, maybe hopefully in a nice ocean under the crust of ice. But there are a lot of exoplanets sort of in that green range. But look how big all those are. These are giant gassy things. So we got lots of gas ones in the habitable zone. Maybe there's a moon. Maybe there's an exomoon in there that could be habitable. Although if it's like Jupiter has this horrible, radiation environment. The magnetic field traps radiation and it kind of cooks the moons that are around it. So it's fun physics, but not so great for life. Now, what about potentially habitable worlds? So things that are rocky, things that are in the right spot. And I love the fact that, again, this Puerto Rican site has this chart. These are worlds that are actually within that right range. Now, many of these are around those red dwarfs. Those red dwarfs flare. They have big, bright X-ray flares. They have horrible things that happen. But life does tend to find a way. And we found even, I forget what they were. They were little bacteria that were like, yeah, X-rays, whatever. UV, whatever. So maybe on these planets that's happened. Yes, most of these might be tidally locked. Well, if you have a deep enough ocean, you have enough circulation, you can move that energy around. I'm not saying it's perfect, but, this isn't a Club Med vacation land you're going to. But maybe life can find a way on these. But so far, we don't have any, like we've been saying, that are Earth 2.0, that are the right distance around a sun-like star, that won't be tidally locked, won't have a star that's going crazy hitting them with X-rays. So we're kind of, I don't know, we're definitely not have the perfect candidate yet. But if you want to look up in the sky and say, are there worlds that I could point at and say that star has a potentially habitable world, there they are. This is a map of the whole sky. The Milky Way is sort of that curving blue line. Picture a map of the Earth when we make it flat like this. Same thing. We took the whole sky, stretched it out, and made it a normal map. So, yeah, you can go out, download this map, go out tonight and go look at well, I don't know if tonight you'll be able to look at one, but almost any night of the year at the right time, it might be cloudy as well, you can go look at them. And that's a fantastic notion to think that you can look at a star, Alpha Centauri, if you're in the southern hemisphere, you can see it. So very cool. The question is, though, which of them has the aliens, right? These are the guys we're looking for. They're dancing, they're happy. These are intelligent aliens. Unfortunately, the ones we're going to find first are probably these ones. Bacteria. Yeah, everybody wants the aliens to come visit us. By the way, I'm not convinced by any of the stuff that people are seeing here. It's just not reliable. We had the stealth fighter. It's really an attack plane, but they call it the stealth fighter. Back in the 70s. 1970s, they were flying that thing around. And that's supposed to be cutting edge technology? No, it's not. Imagine, it's what, 50 years ago? Imagine what they have now. And the pilots that are seeing all these weird things flying around, all these, I forget what they're calling them now, but UFOs in my brain, they like to say things like, they're making maneuvers that one of our aircraft can't do. Well, yeah, no shit. Pardon my French, but no shit. Yeah, there's nobody on board. Those are uncrewed devices. It's a robot flying around. There's nobody on board to kill when you pull 12 Gs. It's not a problem for us to build an aircraft that can pull 12 Gs. The problem is the mushy brain inside here will be killed if you try and do that. So these pilots are using an old view to analyze modern things. Just like if somebody were to say, oh my God, this triangular shaped plane is flying around and it doesn't show up on my radar. That would be a weird thing in the 1970s or 80s. These days, it's going to be even weirder. So I'm not convinced by any of the stuff that people are seeing. I want much harder evidence. Evidence like this, perhaps. This is the exoplanet K2-18b that was mentioned earlier by Sarah and others. This is an interesting planet. A year and a half ago, 2 years ago, something like that, came out with a study and said, we found this chemical, and it seems to be maybe a sign of life. I think it was, I don't know if it was dimethyl sulfide, but it was a related one if it wasn't that exact chemical. And it wasn't a very strong case. It was like a 1 sigma result. Nobody in science believes that. We're like, yeah, whatever. I'm going to go have a sandwich. Come talk to me later when you don't have so much noise in your data. They came back. They got more data. They reanalyzed it. They did more models. And they said, now we have like a 3 sigma result. Still pretty good. We usually like 5. It's like 3.5, they claim. So interesting. Dimethyl sulfide is only formed on Earth naturally, biologically, that is, by little bacteria. Now, it's done naturally by humans in factories. We can produce this stuff in high temperatures, high pressures. Certain environments could do it. Maybe volcanism could do it. There might be ways to create it on this planet, but it's certainly weird. It's certainly a very, very odd thing to see. However, not everybody believes this. I'm not sure I do. When I learned what they did, for example, the yellow dots are the data. The blue is their modeled spectrum. They've gone in and said, what would we expect for an exoplanet like this? And they've put things in until they get the best fit. Well, I prefer this sort of method. This is a paper that came out recently where they went in and said, we're going to go in there and say, let's just fit a straight line to it. See how accurate that is. And then they said, let's fit a single Gaussian. A Gaussian is sort of a bell-shaped curve, but they've inverted it, so it goes down. And then they fit Gaussians to it. Well, one of them's going up, one of them's going down, you can see. And they say, is the fit better when we include a Gaussian, when we include a little bit that goes up? They don't know what's causing it to go up. They're using that as a free parameter. They're just sliding around saying, let's just fit the data. And then they say, well, let's fit it with 2. And it turns out fitting it with 1 Gaussian is no better than fitting it with a flat line. It's not a better fit at all. So there's no information in that bump, essentially, that's much different. The 2 bump fit, the one going down and the one going up, actually is a slightly better fit. So maybe that's real, maybe it's not. But they're still saying this is just not that convincing. When you can basically say the flat line fits just as well as the 2 Gaussians that we're letting float around and we're fitting them to the data, and you can do some statistical tests to say how good is the fit. Turns out it's just not much better than just saying a flat line going across, so nothing. So more work is to be done. However, this is science. This is the fun part of it all. If science were just make a measurement, that's how it is, move on. Okay, that'd be cool. We could learn a lot. But the fact there's back and forth, scientists check one another. Not everybody believes what's happening. There's argument. This is how we get the real truth in things. And this is why it's important to fund science. Because when we have competing groups, group people in Europe, people in the United States, we get to the truth. So this is just another bit of work that's being done. Maybe these folks are wrong. So I look forward to getting more spectra on this planet because maybe there's life there. It's our best candidate right now. In Venus's atmosphere, there's actually some phosphine, which is kind of weird. Some folks say they can make it naturally as well, so we'll see. Hang on to that. I'm going to do this really quickly just because what the heck, why not? We'll do it fast. I want to calculate how many piano tuners are in Santa Barbara, and I misspelled Santa Barbara. I'm a terrible speller. So what do you think? How could we go about calculating this? And why am I doing this? What a weird thing where it's an exoplanet day and now I'm tuning pianos. Hey, stay with me here. How many people are in Santa Barbara? Does anybody know? Yes. 80,000. 80,000?
In the city.
That feels too small.
It's not a very big town. I'm actually from.
Let's go a little bigger. Let's go like surrounding cities as well. 250,000 in the county? All right. So we're going to have to do some math here. Where's my calculator? 250,000. Now, how many people live in each house? What do you think? What's an average number? 2 is probably too small. 15 is probably too big. 4? 4? So we take this number and divide by 4. It'll give us how many houses there are, apartments, places to live in. So let's divide it by 4. So that tells us there's 62,500 dwelling units. There's probably more because some people live alone, some people live in bigger homes. We're just getting some averages here. Now, if we wanted to find out how many piano tuners there were in Santa Barbara, how many of these abodes have pianos? You've all been to people's houses. What fraction of homes have a piano in them? 20%, 1 in 5, 1 in 10. Also, there's pianos in Santa Barbara that need to be tuned at universities and music halls and other places like that too. So again, this is all very just back of the envelope. We're guessing here. We're making stuff up. So let's go with the 20%, whatever. So 1 in 5. So now we'll take our 62,500 and we'll divide that by 5. So that says there's 12,500 pianos that need to be tuned in Santa Barbara, in the general area. Now the question is, how many pianos can a piano tuner tune in a day? What do you think? 2? 1 in the morning, 1 in the afternoon, take a long lunch break? Sounds pretty good. You want to do good work, you want good tuning, you don't want to have somebody tune your piano in 2 hours. I wouldn't trust that. So maybe you get it tuned a lot. Well, actually, let's also think about 12,500. How many times do you tune these a year? I was guessing 1. I said 1, so we could just divide by 1, or we multiply by 1. So I had a class one time that said 5. There was a woman that was adamant. And I was like, you play piano, don't you? And she was like, yes. I was like, okay, we're not talking piano players, we're talking average people, so just 1. So we need to do this many tunings in a year. And let's say you can do 2 per piano tuner. All right, so let's divide this by 2. That means each piano tuner needs to do 6,200, we need 6,250 tunings per year. Did I do that right? No, I don't think I did. I divided by 2. Right now we got how many piano tunings need to be done. Let's divide by the number of days. How many work days are there in a year? 200? All right, we'll call it 200, whatever, good enough. 200, so that means each day we need to tune about 62 pianos, right? Something like that. So now let's divide that by 2 per person. That's 31 people tuning. Now, so number of pianos, what does it actually equal? It flew in again, how fun. Now I went into AI, Google AI, and it told me there are 10 piano tuning companies. How many people work at each one? How many tuners do you think work at each one on average? I'd guess 2, 3. 3 gets us the right answer, of course. 3 gets us 10. But it's somewhere like 2 or 3 people, probably. Piano tuning companies don't have 10 people working for them usually, but it's probably 1 or 2. So you can see how you can just take numbers you know, put them together, and come up with something that's kind of close to the real answer. So now, of course, those of you that have been paying attention today know, and by the way, if you want to know, there's Schwartzner Piano Services, Lisa's Piano Tuning, the Piano Outlet, the Piano Tech, Ashley Piano Crafts, Heather Lavin Piano Studio, Kate Piano Services, Hudson Piano Services, and the Piano Services, it might be one person, I don't know, but I did look into all of this. Anyway, Frank Drake, professor of mine, actually. I knew Frank. I took radio astronomy at Santa Cruz from him. He was a lovely individual, such a nice guy. He was like everybody's grandpa. He was so, so kind, so nice. He had a similar thought, and he kind of thought, well, we can estimate the number of intelligent civilizations that are out there. How many alien civilizations can we talk to if we put together some numbers intelligently? And what he came up with is known famously as the Drake equation. So n is the number that we could contact. Now, this isn't the number that are out there. This is the number that we could pick up or communicate with. If they don't want to communicate with us, or they never did, they aren't counted here. Or if they're locked in a shell of ice and they never learned about the outside universe, they're not counted in here. There could be intelligent life that doesn't know about the rest of the universe. That's mind-blowing to me, but it's totally possible. Anyway, so let's pick some numbers here. The first thing, our star, that's the rate of star formation in our galaxy. We're just calculating it for our galaxy, of course. Recent measurements say that value is somewhere around 10. 7 to 15, depends on who you ask, what kind of stars, but we're going to use 10. Nice round number. It's been the number that's been fairly accepted. FP is the fraction of those stars that have planets. We've learned through the Kepler telescope, the TESS, the others, that number is 1. There's a planet for every star. Almost pretty much every star is going to have a planet. There will be outliers. There'll be some that don't. But again, we're doing back of the envelope. We're doing piano tuners in Santa Barbara here, so we don't need to be too worried. NE is the number of planets in that system that have an environment that's suitable for Earth, for life. So an Earth-like environment, water, things that are warm enough radiation. You heard today, and I had this number typed in ahead of time, it's about 20%, we think. Between 20 and 50% Earth-like planets around sun-like stars even. I did this for you, and I was hand-waving and saying, well, we'll allow red dwarfs in here. But it's probably just the stars like the sun, a little hotter and a little cooler. But if you get too much outside that realm, you either don't live long enough, you blow up or die before the planet has much time to do anything, or you're one of those flaring red dwarfs, which is bad news. FL is the fraction at which life shows up on those. Now, this is a guess. I'm positive. I'm optimistic about this. I think it's 1. I think it's 100%. Life showed up on Earth almost instantly when Earth cooled down. We find amino acids. We're finding the precursors for the chemicals that life needs all over the universe. We're seeing them in asteroids. We're seeing them in comets. We're seeing them everywhere. So I would not be surprised if life, as soon as you get cooled down, you give it somewhere to go, it's gonna start. Now, how often will it become intelligent? This is where I get a little pessimist, and maybe it's based on the current happenings. What's happening right now. Yeah, I don't know. I mean, is there intelligent life on Earth even? I'm not sure, but we communicate. We're communicative, so that's fine. In fact, that's the next one. Does that intelligence learn how to communicate interstellarly? And I'd say yes. If you become intelligent, you're going to start making radio towers. In fact, it's our radar beams, the radar that we use at our airports. That's the most visible thing we're sending out there. Those are really, really bright. Back in World War II in particular, that was some of the first things we were beaming out there. So if aliens look to us, they're probably going to pick up our radars. Everybody loves to think they're going to see I Love Lucy and Gilligan's Island, but probably not. Probably the radar. But I like to think it's 1, that if they're there, they're going to start using something we could pick up. But then the question is, how long do they do that, though? We use radio communications still, but more and more people are starting to use sort of satellite that's small scale, beaming right down at us. They're not very far from us. Also, fiber optics, laser communication, things like that. So who knows how long? Does anybody have a feeling how long we'll be visible? I don't know. I thought 10,000 years, just a number to throw out there. This is the most uncertain number. The others, we can kind of have some rationale behind it. This one is pure spitballing. You're just like, gut feeling, what do I think? A lot of people think the number will be even longer, 1 million, 100,000. Some people think it's short. Back when this was first done, Frank was a friend of Carl Sagan's. There was a lot of pessimism that we would blow ourselves up, that we would have a nuclear war, and we would end intelligent life on Earth. Life would go on. Cockroaches would have a field day probably. But anyway, it was a worry. So now when we multiply all of these out, we end up with a number that says there are 20 communicative, intelligent civilizations in our galaxy. So they're out there. Oops, it crashed. Notice that it crashed. I love that. That was my last slide too. So I love the fact that he was showing, and then we got a pop-up of, no, we can exit you. There we go. So yeah, if they're out there, they're probably very far away. 20 in our galaxy, if you sort of sprinkle them in there, the odds of them being very far from us are pretty big. So odds are they're hundreds or thousands of light years away from us. Space travel is very, very difficult. There's no reason to come to Earth. There just isn't. I would believe mechanical probes coming here before I would believe aliens. In fact, although time travel is probably not possible, in my mind, it would be more likely that time travelers would come from Earth to come visit something else because they know we're here. In the future, they know there's interesting things in the past to come visit, and we know there might be interesting things in the future here on Earth to come visit. Aliens have no notion we're even here unless they're within that light bubble of whatever you want to call it, 100 light years or so. If they're outside of that, there's nothing special about Earth necessarily, other than if you're scientifically interested and you want to know about a rare-ish world that has water, the triple point, it has ice, it has an atmosphere, it has oxygen. So there's certain things that make us interesting, but there's nothing special. You can get all those ingredients from comets, you can go to an asteroid belt, you can mine them there. People talk about coming here to take our water, no, you don't want to do that. You don't want to go down a gravitational well and try and get it from Earth. You would just grab it from an asteroid. So I don't know. I think there's alien life out there, but I don't think aliens like this have visited us, even though I like wearing the t-shirts. But that's all I have to say is right now, we don't have any firm confirmation of life. We've got a lot of places that we're starting to find that maybe might be able to host it. And with the next generation of telescopes, the 30-meter telescope, the extremely large telescope, we're going to start